Hello. Today we are going to be doing Chapter 1, Section 5 of Solving Inequalities. So the first thing is we got to understand how to read it. Okay? Doing these 4 problems, maybe you already know them. You can pause it and try. Alright, number 1. 4 less than a number is greater than negative 28. Alright? First thing we know is what makes it an inequality. Okay, hopefully you remember that inequalities mean less than or greater than, or you can have less than or equal to, or greater than or equal to. Okay, so you're ranking the number, all right? So we're going to say 4 less than a number. Well, hopefully you remember from the last section that that means a number x, and we are subtracting 4, is greater than, so that number is bigger than negative 28. Notice it didn't say anything about being equal to negative 28. Number 2, twice a number, so 2 times some number, is at least 15. Okay, so if I say you have to be at least 15 to be in this class, all right, that means you need to be 15 or older. Okay, so 2x can be bigger than or equal to 15. Okay, obviously that's not true, all right, but 2 times a number is greater than or equal to 15. Number 3, a number is increased by 7, so some number x. Increase means we're going to add to it by 7, and is less than 5, so less than 5. All right. Number 4, the quotient. All right, quotient means division, so that should mean a fraction. All right, so the quotient of a number and 8, so some number and 8, okay, you read it from top to bottom, is at most negative 6. Okay, so it has something to do with negative 6. All right, if it's at most that, you can have at most this many things. Okay, you go to the store, your parents say you can have at most 2 items off the shelf. Okay, that means you can have 2 items, 1 item, or no item. All right, you walk back with 3 items. I don't know about you, but my parents certainly would not let that happen. All right, so you have to have less than or equal to that amount. Okay, so again, this messes people up because it says at most, and then we use the less than sign. You know, we said at least, and we use the greater than sign. Okay, understand, put it into context. That's going to help you. Okay, so add some meaning behind the numbers as you're reading it, and maybe that'll help define what it is, less than or greater than. All right, the next one. All right, so now we're actually going to solve these inequalities. So we're going to start with problem number 5. Okay, so that is a problem number 5. You treat it just like it's an equal sign. Okay, so I don't like this parentheses, so I'm going to distribute to get rid of that. So I have 3x plus 3 plus 2 is less than 11. All right, again, some of you may have remembered how to do these, so I encourage you to pause the video, try it, and then see if you get the same answer. Okay, so then we've got 3x plus 5 is less than 11. Move the 5 over, so 3x is less than 6. Divide it by 3, we get x is less than 2. All right, now for graphing it, okay, I bet there's a lot of people thinking they need their graph paper. Okay, hopefully you're not one of them. Okay, all right, you have a 1 variable here. Okay, so if you think about graph paper, graph has an x-axis and a y-axis for 2 variables. Okay, we don't have 2 variables, we just have an x, so we just have a number line. That's all you need here. Okay, so we can just draw one by hand. Now, I'm not making you put a certain amount of numbers. I'm really flexible here on how you draw your graphs. All right, here we want everything that's less than 2, everything smaller than 2. So you know you want the number 2 on your number line. Okay, we are going to be at that number 2. That's important. and everything's smaller than it. So we're going to shade all of our answers. Well, we could have 1 as an answer. We can have 0. We can have -1. We can have anything to the left of 2. Notice we did not include 2, so I left that circle empty. Okay? This is how your graph should look. If you want to add other numbers, you are welcome to, all right? But I'm not enforcing it. Okay? So when you take the test, you're going to have your inequality answer, and then you're going to have your graphed answer. Okay, I'm looking for those 2 things here. All right. Yes, if you get this one right and you get this one wrong, I will give you partial credit. I do partial credits, but take your time. You guys can do this. Okay, practice it. All right, let's do number 6. Okay, again, I don't like the parentheses, so I'm going to distribute what's in front of it, but I'm going to make note there's a negative. So this becomes 5t minus 2t minus 4 greater than or equal to 8. Combine those t's. 3t minus 4 greater than or equal to 8. Move the 4 over. We get 12. Then we divide by 3. And we get 4. So t is everything greater than or equal to 4. Draw your number line. We know we want the number 4 here, and we want to shade everything bigger than it and including it. So now we're actually going to fill that circle. So this is my inequality answer. This is my graph answer. Okay? All right, let's go to the next problem. Okay. So I encourage you guys to try these on your own. All right, 7 and 8. Pause it. Give it a go. All right, number 7. We're going to distribute the -2. We get 5 minus 2n. I don't know what I'm writing there. Minus 4, less than or equal to 4 plus n. All right, I'm going to combine my like terms. I get 1 minus 2n less than or equal to 4 plus n. I'm going to move this n over, and I get 1 minus 3n less than or equal to 4. Move the 1 over. We get this. Now, when I divide by -3, I hope you all remember this. Whenever you divide by a negative on both sides, so I put the negative there, whenever you divide or multiply by a negative, you have to change your sign. So this becomes n is greater than or equal to -1. All right, don't forget that. Our graph is going to look like this. Everything bigger than -1, including it. All right. Number 8. All right, I don't like that I have fractions, so I can multiply them out. Yes, you can cross multiply. You can multiply by a common denominator. We can keep it simple. We don't like this 5, so multiply the other side by 5. So we get 3x plus 1 greater than, then we're going to have this 5 times x plus 1 over 2. I don't like that denominator, so I'm going to multiply the other side by 2. So 2 times 3x plus 1 greater than 5 times x plus 1. Okay, so when you get the same thing if you were to cross multiply, just don't mess up your inequality. With the same steps. Okay, distribute. We get 6x plus 2 greater than 5x plus 5. Move the 5x over, and I'm going to move the 2 over. So I'm going to get 1x on the left is greater than 3. We graph that. Everything bigger than 3. So hopefully you notice that if you have your variable on the left side and your number on the right side, like we have on these two inequalities, that it also points to where you graph. Notice my inequalities are both pointing to the right, and notice I shaded to the right. if you look on the last two problems, okay, we had it pointed to the left, pointed to the right, and notice how it's shaded. Okay, so that's it's a helpful hint. Okay, but again, that only works if your variable is on the left side. If it's on the right side, don't do it. Okay. All right, so let's do some word problems. Okay, so solve each problem by writing an inequality. All right, the length of a rectangular yard is 30 meters. The perimeter is at most 90 meters. Describe the width of the yard. All right, word problems, I don't know what it is, but people get overwhelmed when it starts putting math and a bunch of English together. I don't know why. It's the applied part. This is more like the sciencey part, okay? So we're going to talk about a rectangular yard. So let's draw it. All right? Usually the last sentence tells us what we're looking for. We want the width of the yard, so I'm going to call that W, okay? So I'm going to label my width on both sides. Okay, so now let's go back to the beginning. The length of that yard is 30 meters. Okay, go ahead and add that to our figure. The perimeter is at most 90 meters. So P is at most 90. So it can't be any bigger than 90, so it's less than or equal to 90. Well, how do we get the perimeter? We add all the four sides. So we're saying W plus 30 plus W plus 30 has to be less than or equal to 90. And notice how I figured out my inequality. All right? You can logic this out. Okay? You just have to think about it. All right? It's just that simple. People keep thinking that math has to be harder than that. No, it's really that simple. Okay? All right? So, add these up. We get 2W plus 60. Oop, almost did the wrong inequality. And 30. There we go. So 2W is less than or equal to... Why am I writing 30? I'm already doing the problem. Silly me. Okay, so now it's 2W is less than or equal to 30. So W is less than or equal to 15. So the width can be at most 15. Okay? And then we could logic it out and say even more to it if we wanted to. Think about it. We're talking about the length and width of a yard. What can't your number be? Right? It can't be anything less than 0. All right? So that's one other thing. But this is how we'd solve the problem, because that's specifically what it was asking. Okay? Something just like that. Okay? The width is at most 15. All right, let's do another word problem. Okay, so let's see. She wants to buy a laptop that costs $500. Anything else will be $65 extra per feature. Her parents are only willing to spend $800. So how many features can she get? So we want to find features. So that's going to be F. Okay, so we know it's already going to cost her $500. And then every other feature is going to be plus $65 more. So $65 per feature. All right, we've done that word problem before. Okay, then we can set it not equal to, because think about it. Her parents are only willing to spend $800. But if you came to your parents and said, I found a laptop for $400, do you think they would say, no, you can't get that? Certainly not. My parents would love a deal. So they can spend $800 or less. Okay? So then we can just solve it from here. So 65F is less than or equal to 300. So let's see, I gotta find my calculator. 300 divided by 65 is something gross. So you get 4.615384462, blah, blah, blah. All right. Now, what does that mean? I say How many features can she get? She can get at most, what, 4.615 features? No, that would be silly. I can't go in there and buy part of a feature. Okay, that does not make sense in this word problem. So we cut off the extra. The number of features she can get is 4 or less. Okay, you can't buy part of a feature. So keep it within the context of the word problem. All right, so the answer is she can get at most 4 features. Okay, all right, next one. All right, so let's see. This is the always, sometimes, or never true. Okay, so let's see what that means. Okay, I get a lot of people that go, well, I don't know how to do that. Okay, you're right. Let's look at what it means. Let's solve it. Okay, so distribute. So we get 6x plus 3 is greater than 5x minus 2 plus x. Distribute that negative. All right, then we get 6x plus 3 is greater than 6x minus 2. Well, when we subtract our 6x, all right, we get 3 is greater than negative 2. If you had moved the 3 over, you would have gotten, what, 0 is greater than negative 5. Okay, well, I lost my variable, okay? I have nothing here. I have 3 is bigger than negative 2. Well, yeah, that's a true statement, okay? 0 is greater than negative 5. Well, yeah, that's another true statement, okay? Trues. I don't know why I did that. All right, so here, think about what this is saying right here. Sorry about that. So think about what that is saying. We have 6x plus 3, and it must be bigger than 6x minus 2. Doesn't matter what x is. It's always going to be 6 times whatever the same number. We're going to add 3 to it over here, and we're going to subtract 2 subtract 2 from it over here. So you can see that the left side is always going to be bigger than the right side. So this is an always true, didn't register that, true statement. Okay, always true. All right, what about number 14? Let's see what happens. 7x plus 2 is less than or equal to 4x minus 8 plus 3x. We get 7x plus 2 is greater than or equal to 7x minus 8. Look what happens again. We get 2 is less than or equal to negative 8. That's false. That makes no sense, right? 2 is not smaller than negative 8. Never going to happen, okay? So if you think back to your original equation, 7x adding 2 to it, and the right side, 7x minus 8 from it, the left side is, of course, never going to be smaller than the right side. So this is a never true statement. Okay? Doesn't matter what you plug in for x. This is never going to be true. Okay? So that's always, that's never. Well, when do you get sometimes? Think about what we had before. Think about our previous answers. F is less than or equal to 4. Well, F can be 4 here, F can be 3 here, F can be 2 here, but F can't be 5, F can't be 6, so F is sometimes true. Okay, that would be like a sometimes true statement. Okay, that's the difference. All right, so hopefully this made sense to you. I'll see you at the Zoom call if it didn't. All right, bye.